Hello everyone. I'm gonna make another video right now to explain why I think there was actually no kinetic impact between the Earth and the Moon to cause this feature. And it's not just what I think, it was what I was learning about classical physics, 19th century physics. I was learning the Lorentz force. This stood out. Faraday's law of induction. So if there's a flux in the magnetic field, it's going to induce an electric current. And temporarily imagine this is the moon and it's trying to get closer to the Earth. That's going to cause the flux in this area, which causes an electrical reaction between these two. If this were to get closer, and if we're coming around here to our orbit, where this is coming in this direction as this is coming down to meet almost, if you remember, we're trying to start with this to end up with this. And we also have our moon, which I haven't talked much about this, but this almost looks like it was scarred while it was burning in, trying to, like, just imagine this is a giant meteor almost, and it was burning in as it's entering the Earth's atmosphere, getting closer. But as that's happening, the distance between the spark gap, that's decreasing very, very rapidly. And at some point in time, there's going to be an electrical reaction before there's a kinetic impact. So if you have the force of motion, if it's coming in this direction and two are coming in at one another, well, at one point in time, this current has to come over here, which is then going to point up, and that redirects the force of motion this way. So, in essence, the Earth, there was no kinetic impact, is what I'm saying. The force is that powerful, I think, and that was kind of profound for me when I even considered that, because now this is like, we're actually safer than I ever imagined, if you think of it that way, because you're throwing the moon at the Earth, and physics over here is telling you that this is going to redirect the force of motion by the 90 degrees. When the current sets to flow, and inevitably the spark gap's going to decrease. That's happening very rapidly, which Faraday's law of induction, at some point, these things are going to come into play, and we come back over here to our equation, simple equation, and we see this equation. We can get a lot out of this because this voltage kind of acts like the demand to move the charges. When you come over here to the world, when you're having an intense change in this region, which causes charges to redistribute across the Gaussian surface of Earth. And that's how we see all these patterns in line. And that's why it looks like it's a cohesive one event. It can be one event here. And the cool part about it, it's not something that we have to like worry about, like, can this happen again? So that was like really fascinating for me. Like, now I'm gung-ho, let's go look, let's go find more. And that we're going to talk more about. Because if it's coming it's not just the actual Earth that's resisting this. This is the electromagnetic force that is preventing it. And we actually see this in a lot of things, like why the comets burn up. They're being etched away. They're going against, these bands are coming in electrically from the side as these magnetic fields kind of guide the flows of the current, is how this all works. But when you apply it to the scale like this, and then you consider the spark gap, coming in from here, and this one is coming in from here, and if you can imagine these two coming towards another, but this intense fluctuation in this region would cause charges to redistribute elsewhere. But if you look at this for a second and imagine if this were a larger, this is the Earth here and this is the moon, and when the moon comes in here and you have this electrical reaction in this direction, and then you go back and you apply the Lorentz force and all that stuff, and now we actually redirect our force of motion. Between these two, but then that technically opens up a whole nother world, because now this gets, again, it's a little more real. We have the ability to actually transform this into this in a relatively short period of time. I don't think you need hundreds of millions of years. I only think that you do not need hundreds of millions of years. I think if anything, we're observing the rate as it's slowing down. It's still cooling off from when this happened, whenever that was. I don't know how many other planets have a fractured crustal surface, but that seems pretty unique to Earth, if I'm to understand that correctly. And that's where, again, I had to go back and revisit some of the concepts that I originally learned, but I didn't really understand anything about Faraday's law or the right-hand rule. And I mean, I knew a little bit about a spark gap, but not. But I'll tell you one thing, if you're coming over here to the orbits, and this spark gap is decreasing at, one of the rates that these things are traveling, and then you combine the rate from this and the rate from that, and then that gets converted into flux in relationship to the magnetic field. We have this barrier that's going to protect us, and it does against the solar flares. This is actually why I don't think it was a solar flare, because when the solar flare strikes, you build a saturation level, and that causes another layer of protection to form. You get another band of a magnetic field that comes around here. So you still experience reactions down here, but the charge from here causes effects into this layer, and then that affects this layer, and that affects this layer, and then eventually you see the reactions occur down here on Earth. It's not like an immediate thing. But with the moon, I mean, we're coming in, there's not a lot stopping it, because you have the force of this sending this around, and this sending this around. And then you add potential amperage from this circuit and potential amperage from this circuit, and you come back to this equation, and now you're packing heat, to say the least. And when you come over here, that's a pretty big object. But when you size it up to this, it's about relatively proportional. And then you look at this, and this looks like the physical resistance of the Earth. I haven't talked much about this feature yet, but there's this large, distinct semicircle feature in opposition to the smaller. And this almost looks like it was created by an arc that had to come up and balance with the moon. The moon looks like it was pulling in from this as it came in from this side. There's the blowback, the need to take charge from this side of the planet, send it over here. But then we still haven't even talked about this, which is a whole nother whoa. Because here we are. And then you got to think about alternating current, north, south, north, south, north, south. But why are the scientists not applying this is what I'm concerned about, because this really makes sense. But that gets a little bit like, if you take that and you have to recognize this, but in reality, if you do recognize this, how safe do you think we actually are? And granted, this is a lot of destruction this probably caused when this happened, but if you can actually prevent an object the size of the moon from a kinetic impact merely by applying the laws of physics accordingly, and observe nature as it is, and everything seems to fall in line. Like, this is why you have these features. And it's not just electrical, it's all three components here that we're seeing on the globe and elsewhere. Alright, good luck everyone, I'll make more.